Hello. So in this video, we're going to talk about multiplication rule for probability. Using the wording "and" in a question of probability to examine the probability of a sequences of event. It will represent the probability of seeing more event and then some other event. When finding the probability for a sequence of event, we use multiplication. Okay, that's too complicated. So basically, the multiplication rule, also known as "and" rule, states that the probability of two independent events occurring together is equal to the product of their individual probability. Okay, so here is our first example. Imagine that we have a sample of 10 jelly beans. From this set of 10, we are going to draw 2 jelly beans. If we draw the jelly bean with replacement, that means we put them back. We draw one in and we draw one out and put them back in the bag, the sack. What is probability of choosing a green jelly bean and then a red jelly bean? So this is two events. They occur together. They're not trying to draw one jelly bean, blue, and then green and then it happened to be red at the same time. This is different than what we talked about in the earlier video. This is doing it twice. The first time we draw a green one and then we draw another, we put the green one back and draw another one, also is red. So the probability of drawing a green bean and then a red jelly bean with replacement, that is very important. That means the total amount of the jelly bean remain the same. It's going to equals to the probability of drawing a green bean times the probability that you are drawing a red bean. Because the "and" rule says that this is equal to the product of the individual probability. So what's the probability that drawing a green bean? It's going to be 3 out of 10 times the red bean is going to 4 out of 10. So total combined is going to be 12 out of 100. You need to simplify it. So we've got 3 out of 25. Or you can write 12%, either way. Now, if we draw jelly bean with replacement, what is the probability that choosing a red bean and then a purple bean? So we use the same method. So the probability that we're drawing a red bean and then a purple bean is equal to the product of the individual probability, which is a red bean multiply a purple bean. So the probability of drawing a red bean is going to be 4 out of 10 times the purple bean, 2 out of 10. Total combined is 6 out of 100. Or either reduce the fraction or write as 6%. Oh, sorry, it's 8, not addition. This is multiplication. Should be 8 out of 10 or 8%. When you simplify this, should be 2 out of 25. Okay, so two events are called independent if knowing that one occurs does not change the probability that the other occurs. Like our previous example about flipping a coin, you're flipping a heads up, that's one event, and knowing that was Friday. This is two independent events. All right. So for two independent events, if we want event A and B happen, the probability is equal to PA times PB. Example, if we're drawing a jelly bean without placement, that means once we draw one out, we don't put it back. That means you originally have 10 jelly bean. When you draw one out, you don't put it back. So you only have 9 jelly bean left in the sack. What is the probability that choosing a green jelly bean and then a red jelly bean? So we want a green bean, then a red jelly bean. Be careful, is without replacement. The number of the total jelly bean is going to change. So this is equal to the probability of you join a green bean, then multiply the probability that you join a red bean after you draw a green bean. I write this up to remind myself that, hey, the number of the total jelly bean is changed. So originally, how many green beans we have? We have 3 green beans out of 10. And then after we draw 1 green bean out, there's only 9 beans left in the sack. So the total number of the beans is 9, but the red bean doesn't change. The red bean is 4. The number of red bean is 4. So the probability should be 3/10 times 4/9, which is 12 over 19. When you reduce it, you should have 12 out of 15. Or you can write it in a fraction way. If we draw jelly beans without replacement, what is the probability that choosing a purple jelly beans and then a green jelly beans? So I would like you to pause the video and try to do it by yourself and come back to check the answer. Okay, now in here we're drawing a purple jelly bean, then a green jelly bean. So the probability of drawing a purple jelly bean times a probability that drawing a green jelly bean after a purple jelly bean has been drawn, what happened? So for the purple jelly bean, you have 2 out of total number 10. And then we're going to multiply the number of green bean out of the rest of the beans, which is 9. So in here we have 6 out of 90. Simplify, we have 1/15. All right, so here says that for dependent events, which is in our previous case is dependent because after you draw one out, you're going to change the total number of beans. PA and B is equal to PA times B given A. So given is the conditioning probability. So 10% condition. When we sample less than 10% of the population, the probability can be assumed to be independent. For example, in here, say we were looking at all Americans who wanted to find the probability of selecting 2 Americans with blue eyes, given that 17% of the Americans have blue eyes and there is a population of 329.5 million. So if you're choosing 2 people with blue eyes, yes, after you draw 1 people out, so the rest of the numbers should be 329.5 million subtract 1, right? That should be your total number for the second man that you're trying to draw as a blue eyes. But by the 10% rule, since 2 is way less, the sample is so small, it's less than 10% of the total population, which is 300 million. So we don't need to worry about that subtracting the 1 for the total number because it won't make that much change for that. So that means our probability is going to be the probability of 2 blue eyes, 1, let's say it's not 2 blue eyes, I was wrong. We're looking at 2 American. For the first one is a blue eye. Then and then we find another American also blue eyes, so equals the probability that the American has blue eye times the probability that the second American also has blue eyes. So it should be 17% multiply 17%, whatever that is. Okay, that's it for today's video.